My wonderful viewers, I welcome you all once again in our today class. We are given this very set of problem. We are given the matrix A as this and the matrix B as this, and we are told to find the transpose of matrix A and the transpose of what? Matrix B. Okay. Now, when you hear the word matrix, what comes to your mind? Anytime you see numbers arranged like this, okay, in brackets, in this order or manner or pattern, we term such arrangement as what? Matrix, okay? So we say that matrix are a set of numbers, okay, or element arranged in a what? In a rectangular what? Pattern, okay? So these are termed what? Matrix. Now, you taking a look at this matrix, they are arranged in order of what? Rows and what? Column. What do you understand by the row? Notice in this direction, as you are moving like this, from your left to your right, all the numbers moving from your left to your right in this direction are referred to as what? Are under the what? The row. Okay, so this direction are referred to as what? Row. Then while all the numbers are arranged like this, up and down like this, are referred to as what? Column. Okay, so in this first matrix A, we notice that there are two rows here, row 1 and row what? 2, right? So then we also have column 1 and column 2. So this is a 2 by 2 matrix. We call 2 by 2 matrix a matrix that has 2 rows and 2 what? Columns. Okay. Now looking at matrix B, how many rows can we find here? We have the first row, second row, third row, and fourth row. So there are 4 rows in this matrix what? B. Now let's find out how many columns we have here. Column 1, column 2, column 3, and column 4. So that means we have equal number of rows and column in this matrix. So therefore, we call it a 4 by 4 matrix. Why this one is a what? A 2 by 2 what? Matrix. So you can equally say that they are square matrix. They are square matrix in the sense that they have equal number of rows and columns. So what are we meant to do in this question? We are asked to find the transpose. What does it mean to find the transpose of a given matrix? Okay, now if you are asked to find the transpose of a given matrix, let's say the matrix A now, okay, what is the transpose of matrix A? Now initially we are given our A to be this, our A is equals to what? 3, 2, 1, 4, okay? Now how do we transpose this? To get A transpose of a matrix simply means interchanging the rows with the what? Column. Okay, when you interchange this row with the column, it becomes what? The transpose of that matrix. Now, how do we interchange rows and column? Now, this is our what? Our row, right? You can see the arrow here indicating that this is our what? Row. Why this is our what? Our column, as you can see here. Now, when you want to transpose, okay, how do we transpose? You can see this column we have here. The whole of this row here, okay, if you take it like this, you can see the arrow now is like this. We have 3, 2. When you turn it this way, what are we going to have? When you are turning this number like this now, okay, what happens? The 3 is the first number, while 2 is the second number. So we are turning this way, the 3 goes up, while the 2 comes what? Down. So in that way, we have transposed this first row to become our first what? Column, okay? So in that case, you're going to have what? 3, 2, okay? So we have transposed the first row now to become our first what? Column here. Now we'll come to the second row. What you have in the second row is 1 and what? 4. You can see the direction of the arrow. 1 and 4. So if you tilt this arrow in this direction, what happens? This 1 goes up and the 4 comes what? Down. So immediately we are going to have 1 and what? 4. So this is the transpose of what? A. And that is the final answer to what? To this. So the transpose of this matrix A will give us 3, 1, 2, what? 4. And they are still maintaining the same number of what? Rows and column. Okay. Now let's go to B. The B aspect, where we are given what? The matrix B as this. Okay. The matrix B, we have it as what? As this. 1, 5, 9, 13. Here we have 2, 6, 10, 14. And here we have 3, 7, 11, and 15. Then lastly, 4, 8, 12, and 16. So we can see this our arrow indicating the direction of our what? of our rows, while this is the arrow indicating the direction for our what? Our columns, okay? Now, taking the first row we have here is 1, 2, 3, what? 4. So, taking the first row and tilting it in this direction, we are going to have what? 1 first, 2 second, 3 third, and 4 as what? Fourth, in terms of the position of our what? Our first column, okay? So, this will become, we have what? 1, 2, 3, and 4. So invariably now, our first row in the matrix A has become our first column in the matrix of B what? Transpose. Now let's go to the second row. Second row, we have 5, 6, 7, 8. So invariably, if you treat it this way, the whole of this second row becomes our second what? Column. So I'm going to have 5, 6, 7, and 8. Now coming to our third row, the whole of this third row invariably becomes our what? Third column, okay? Having this as 9, 10, 11, and 12. Then looking at our fourth what? Row, okay? Fourth row invariably becomes our what? Our fourth what? Column, okay? So having 13 as first, 13, followed by what? 14, 15, and what? 16. And this is our final what? Answer. So I would love you, my viewers, to attempt this. Let's say you are given the matrix C to be equals to this. So here we have 7, 8, 9, and here we have 5, 4, 2, and we have 3, 6, and let's say here 10, okay? Can we find the transpose of what? T, a matrix what? C. So what is the transpose of this matrix C? I would love to see your answer in the comment section. Thank you so much for joining us in today's class. We hope to see you in our next class. And do well to invite your friends to join us in this wonderful and interesting class. Bye-bye.